So on to the next video. I just introduced the concept of Zwitter ions. That is the pH. It's the pH at which the particular amino acid will act as both an acid, therefore giving off H+, and a base, therefore taking up H+. Now, I'm just going to show you an example of what would happen in different solutions. So, say amino acid has pH of, say we have a pH of 7 as isoelectric point. What would happen? If we put it into a solution buffered at pH 3. Now this buffered at pH 3 bit just means that it's kept at a constant pH using a certain substance to keep the pH constant. So we can see that the amino acid, so our amino acid should be able to rattle off the structure now because I've drawn it so many times. So what's happening is the amino acid will react to whatever pH the solution is in. So the pH 3 is an acidic solution, so this pH 3 is acidic. Now the amino acid will want to counteract that acidity, and it will try to bring the pH up to pH 7. So how will it counteract acidity and try to bring it up? So to counteract an acid, it must turn into a base. So what it's going to do is that there are all these H pluses in solution which are making the pH 3. So the amino acid is going to say, hey, I want to get this pH 3 back to pH 7 because that's my isoelectric point where I'm most comfortable. So the amino acid is going to go, I'm going to take up H pluses. So this will go onto the amino acid. The lone pair disappears because the H plus will sort of take the lone electrons into its own orbit, and we get an NH3 on the end. NH3. And of course, this will have a positive charge, as it was H plus before. Now, let's reverse the situation. Let's say that amino acid has an isoelectric point of 3, and it's put into a solution, at pH 7. Okay, so what's going to happen here? We'll draw the structure first. So we have CrH, C double bond OH. Then we have our NH2 group with the lone pair of electrons. So what's going to happen here is that the amino acid is going to say, hey, this pH is too high. It's pH 7. I want to be a Zwitter ion at pH 3. So this guy is going to want to lower the pH. And how do you lower the pH? Well, at the moment the solution is pH 7, so it's sort of neutral. But the amino acid says, I want to lower the pH to get it to my isoelectric point, which is an acidic isoelectric point. So what it's going to do is it's going to give off H plus to make the solution more acidic. So this H plus will dissociate, go into solution, H plus, and we get this O, which I'll just make more clear, we get this O becoming a minus. So if I just draw the carboxyl group separately, what we'll get is that with a minus on it. Therefore, the amino acid will have an overall negative charge because the solution has a pH that's higher, it wants to lower it. So in order to lower the pH, it must become an acid, and therefore the amino acid gains a negative charge. Now, this property of amino acids is useful for when you have a sample of protein or a sample of amino acids and you want to separate them out. And this is done by a process called polyacrylamide gel electrophoresis. Now, don't get intimidated by the name. It's a pretty simple process. It's also known as PAGE, by the way, if you don't want to rattle off that huge name. So we can use this property of amino acids to gain either a positive or negative charge in different pHs to separate a sample of perhaps several amino acids out. So what you actually do is that imagine if there was a big well. Excuse the drawing, I'm a pretty dodgy drawer. And we run a current through this gel, so there's a voltage across the cell. There's a potential difference, so we'll have positive terminal here and a negative terminal here. Now in this well, so I'll just label this well or container, whatever you want to call it. It's usually referred to as a well, I'm fairly sure. You put in this polyacrylamide gel, and the gel, so polyacrylamide gel is sort of just floating in the well, and it's buffered at a pH of roughly, well, it can be buffered at any pH, so a pH of X. Let's just say pH 8. Now, if you put a sample of amino acids in the middle, so I'm putting my sample of amino acids, which I'll represent just as a line like that, so a sample of biological material containing amino acids. Biological material. What's going to happen is the amino acids will react to this pH of 8. So all the amino acids that have an isoelectric point lower than 8 will want to make the solution more acidic. Because if you think about it, if their isoelectric point is lower than 8, they have to try and lower this pH, which can't be lowered, by the way, because it's buffered at this pH. So anything with a isoelectric point below pH of 8 will want to lower the pH by giving off H+. And remember, by giving off H+, it gains a negative charge. Therefore, anything with an isoelectric point below 8 will move to the positive terminal because it wants to lower the pH, therefore it will give off H+, therefore it will gain a negative charge, and it will move to the positive terminal. So anything, or any amino acid rather, amino acid with isoelectric point lower than 8 will move to the positive terminal.